Okay, determination of the empirical formula of silver oxide lab. This is section 2, the pre-lab questions. So let's go over this. A piece of iron weighing 85.65 grams was burned in air. The mass of the iron oxide produced was 118.37 grams. Number 1, use the molar mass of iron to convert the mass of iron used to moles. So here's the mass of iron, okay? Let's type it in here. 85.65 grams have to be converted into moles. You can use the mole math to know what to do. So if you have the grams, the mass, right? You divide the grams by the molar mass of iron, you will get the moles. So that's what we need to do. Divide the mass by the molar mass. And the molar mass of iron is 55.85 rounded, right? You can see there. 55.85. Let's round it to that number. So we need to divide this mass by 55.85 grams per mole. And the result should be the moles. Okay, so let's do this. I have a calculator over here somewhere I can use. There you go. What do we need to divide? We need to divide 85.65 by 55.85. Yep. And you get 1.53 grams. 1.53 moles. So this is 1.53 moles of iron. Okay, moles. Right. Number 2 says, according to the law of conservation of mass, what is the mass of oxygen that reacted with the iron? Well, you started with this mass of iron, and then now you ended up with this mass of iron oxide. The difference is the mass of oxygen. So we have 118.37 grams minus 85.65 grams. And that is the way you get the mass of oxygen. So we're going to do the math here for you. 118.37 minus 85.65 grams will give you 32.72 grams. So 32.72 grams of oxygen. Okay, that's how you get it. So these grams of oxygen means how many moles convert. That's what number 3 is all about, right? So calculate the number of moles of oxygen. Well, we need to divide this by the molar mass of oxygen. I mean, for those of you who do not remember yet, the molar mass of oxygen is 15.99, which is rounded to 16, right? 16 grams per mole. And that will give you the number of moles. So 32.72, I already have it here in the calculator. Divided by 16, 2.05 round, 2.05 moles of oxygen. So these numbers are important. The moles of iron and the moles of oxygen. This is important because of the next step that we have to do. It says, use the ratio between the number of moles of iron and number of moles of oxygen to calculate the empirical formula of iron oxide. Note, fractions of atoms do not exist in compounds. In the case where the ratio of atoms is a fractional number, such as 1/2, the ratio should be simplified by multiplying all the atoms by a constant to give whole number ratios for all the atoms. For example, H over 1/2 should be H2O. Okay, so we have to do the same here. So the next step is to get the empirical formula for iron oxide. So I have 2 moles here. The smallest value is this one. I'm going to divide both of these numbers by the smallest value. So for iron, I just divide by the same amount, 1.53 divided by 1.53, and I get 1. For oxygen, I have to divide 2.05 by 1.53, and that would be calculator here. Okay, so I have 2.05 divided by 1.53, 1.34. So that's the number I'm going to write down there. 1.34, 1.34, 1.35, around that. All right. So this is a molar ratio. This is for oxygen. This is for iron. So if we could keep fractions, then it would be something like Fe1 or 1.34, but that can't happen. So we need to multiply these numbers by a whole number to get whole numbers at the end. So by what number we can multiply 1.34 to get as close as possible to a whole number. And I was doing several trials, and I found that when you multiply this number by 3, guess how much you have. So let's do it. 1.34 times 3, 4.02. That's very close to 4. So we can say very much it's going to be 4. Okay. So we can keep this number as 4. But if I multiply by 3 over here, I have to multiply also here by 3. So I'm going to get 3 for this one. Okay. So that is what I got. 3 items for every 4 oxygens. Okay. So that's what you need to write down here. Metals first, Fe3, O4. And that is the empirical formula that we're looking for. Okay. Now, if you look online, that's not what you will get. Usually you're going to get Fe2O3. But what happens in reality is that this is a different form of iron oxide. Okay? It's called magnetite, and the actual way you write it down is this way: FeO, and there's a dot there. I won't be able to put it there, but I'm going to put this. Let's put it this way, okay? Fe2O3. Okay. So that's the empirical formula. This one here. That is the empirical formula. Is correct for our exam. And that is the end of the pre-lab questions. Also, I wanted to do this together with you. I actually wanted you to do it first, then you can check the answers with me here later. Basically, this is what you need to do in the lab to get the empirical formula for our case, which is going to be silver oxide. Okay. And that is the end of this section recording. Next section is data and analysis.